Good afternoon. We will continue our discussion on feedback. So, last day we discussed about the basic structure of the feedback and what are positive feedback and negative feedback, and we also discussed what are the advantage of negative feedback. So, if we summarize that negative feedback, it reduces the gain, but stabilizes the circuit, and also the input impedance and output impedance are also modified, and sometimes this negative feedback helps as an to make it as a better amplifier, okay, that we will check later. And another advantage of negative feedback is that the sensitivity is reduces. So, we have seen that if we have a general feedback structure, so we have A and this beta is our feedback and this is subtracted from the main input, and we get that closed loop feedback factor is A by 1 plus A beta, that we have derived last day. Now, considering this structure, okay, if we see about this structure, so this is a non-inverting amplifier, right. So, if we want to model this with two port network, so this is our input, and if we consider that infinite input impedance, so this is our gain block, that is, suppose this is having open loop gain as A, so this is A, and say this is our Vi. Vi is the differential input, right. This between this terminal and this terminal, what is the difference, that is Vi. So, this should be A into Vi, just like the model we have used in the BJT and MOSFET, same way we will be using, and we know that output impedance of this is 0, right. So, that we can neglect. Okay. So, this is our two port network of this amplifier, and what are the internal connections? From the output we are having two resistive feedback, right. So, this resistor and this potential is coming to us this Vi. So, this is our R1 and this node is going to this differential Vi is this Vs minus of this voltage, right. So, Vi will become Vs minus Vf, right, and there is another resistor, that is R2, and that is our V0. So, what we just did, we just this op amp we replace it with its model. What kind of model? Ideal model. Input impedance infinite, output impedance 0. So, it is a simplified version, and gain is open loop gain is A, ideally A is infinite or whatever you say. So, this is the structure, right. So, what portion of V0 is coming is as a Vf? V0 into R1 by R1 plus R2, clear. So, we will be subtracting this from the Vs, right. So, our Vi is Vs minus Vf, and what is our V0? A into, right. So, if we follow these steps, then we will see that our closed loop gain is roughly 1 plus R2 by R1. Why we are saying roughly? Because we are neglecting this one portion. We are considering that A beta is much larger than 1 and it becomes. So, what is beta? Our feedback voltage ratio, right, feedback resistance ratio, that is coming as 1 plus R2 by R1, clear. So, what is beta? Can you tell me what is beta? beta is Vf by V0. How much it is coming? R1 by R1 plus R2. And what is your closed loop gain? 1 by beta, na? 1 by beta means R1 plus R2 by R1. That will come as a 1 plus R2 by R1. So, this is our feedback. Now, let us discuss about the property of negative feedback. So, we know that closed loop, for a closed loop, our gain is A by 1 plus A beta. Now, if you take a derivative of this, it will become dA by 1 plus A beta whole square, right. So, that from derivation rules we know. So, dAf is equal to dA by 1 plus A beta square. Now, what was our open loop sensitivity? What is sensitivity? Change in delta change by the total amount. Okay. So, open loop sensitivity, that was dA by A, and what is our closed loop sensitivity? DAF stands for closed loop by AF. So, DAF we already know, we will divide it with AF. So, what we will get? 1 by 1 plus A beta into dA by A. So, that was our open loop sensitivity, and the closed loop sensitivity is increased or decreased? You are dividing with something, na? So, it is decreased. So, what we can say, that our sensitivity is decreased. So, what is the meaning? Is it good or bad? It is good, right? If there is any change, that will affect us less, right? If there is any change in the parameter, that will not change the gain in a big way, because our sensitivity is getting reduced by the utilization of what? Negative feedback. So, negative feedback is helping us to reduce the sensitivity. We are talking, na, desensitizing the gain, right. See, let us talk here again. Our open loop gain, that may be large, but do we have any control? We do not have any control. It depends on what? Maybe GM, we discussed, na, that gain is for GMRC, right, for common emitter configurations, right. So, we do not have any control over the transconductance. This depends on the technology parameters, right. Now, if temperature is changing, this may change and gain may change, but our closed loop, what is that? 1 by beta. What is that 1 by beta? 1 plus R2 by R1. Now, you see, think about this. This is a ratio of resistance. Suppose temperature is increased, R is increased, but both R2 and R1 they will be increased. So, ratio will be more or less constant. So, now I have a control here. I had no control here, because it was dependent on the technology parameter and very much sensitive. But because I am using the feedback and I am using the negative feedback, what is happening? My gain is getting desensitized, desensitivity. The sensitivity of the gain is getting reduced. By which term? The same term, my gain was reduced, 1 plus A beta. So, this 1 plus A beta you will find everywhere. By 1 plus A beta times, my gain was reduced, and by this also my sensitivity is reduced. Clear? Let us continue. Now, we are seeing that this feedback also helps us to increase the bandwidth. So, what is the meaning? Suppose I have an amplifier that I can use for say 10 megahertz in open loop. Same amplifier, if I use in closed loop, maybe it can be increased as a up to 100 megahertz. So, this is in closed loop, this is in open loop. So, in closed loop means generally by default what we will understand, which feedback? Negative feedback. So, what is happening by using the negative feedback? My bandwidth is increasing. Now, let us just quickly do this, that how this is increasing. We discussed this little bit. Suppose A, previously we discussed A na. Now, we are thinking that this A is a single pole system, just like a RC network. Okay, if you have a RC network, then you can calculate the transfer function na, V0 by Vi in terms of S, that you can. So, if you do that, if you find it 1 by Sc and R, if you calculate this transfer function, what you will get? Say roughly we are approximated as Am by 1 plus S by omega h, Am by 1 plus S by omega h. So, what is Am? Am our gain, DC gain. At DC means at 0 frequency, this is our gain. And what is omega h? The corner frequency, right. Okay. Now, what we will do? In closed loop, what is our gain? A by 1 plus A beta. In terms of A, what we will do? We will put this equation, just you do. So, what we will do? Am by 1 plus S by omega h by 1 plus Am beta by 1 plus S by omega h, and you calculate it. We are dividing with this portion. Okay. See, what is this structure? 1 plus S into tau. So, this lower portion also we are making it like 1 plus tau S. So, to do that, what we did? We divide both numerator denominator by 1 plus M by beta. So, now your omega HF, it is what? Multiplied by something, right? Previously it was only omega h, now it is. So, what is the meaning? Previous my bandwidth was say 10 megahertz, now it is roughly say 100 megahertz. So, what is the meaning? The closed loop feedback, see I did nothing, I just expanded this equation, and by doing so I am seeing that my expression 1 plus S into tau, and from that tau we are getting this corner frequency, it is increased, and the gain is, previously my gain was what? Am. Now, in closed loop my gain is what? Decreased. So, if you see this waveform, now you will understand. Previously my gain was more, but bandwidth was less. Now, my gain is reduced, but bandwidth is increased. So, what is the meaning? It is not that everything will be in your advantage. By using the feedback, you are able to use this amplifier for a much higher frequency, that is your advantage. But suppose previously it was giving 60 dB gain, now it will be giving something less, clear. So, it is not that, you know that negative feedback, our gain is getting reduced, right, A by 1 plus A beta, we know that gain is getting reduced, but what others advantage we are getting? That is stability is increased, bandwidth is increased, input impedance is increased. Okay. So, this negative feedback sometimes it helps to overcome the noise, effect of noise also. This is clear? Okay. Let us continue. Now, we say that we discussed last day that we have 4 basic type of feedback configurations, and one type was we discussed voltage feedback amplifier, right. Next is what? Current feedback amplifier, next trans resistance, next transconductance. So, 4 configurations, right. Now, can you tell me, we discussed this before also, a voltage amplifier input impedance should be High or low? High. Op amp, you think about op amp. Input impedance should be high. Output impedance should be low. For current it will be just opposite. And for transconductance and transresistance we will make a mix of that, right. So, that we know. Now, another topology is used to define these terminologies. So, one is voltage amplifier, another is we discuss this. Input side what we are doing? We are mixing the voltage, right, subtracting. So, this is voltage mixing. Outside we are taking a portion of the voltage, right, sampling, voltage sampling. So, this is one naming way, methodology. Okay, these are some terminologies that is used. Another way was, you see the output, it is connected in parallel, right. We discussed last day also that if it is in a parallel connection, voltage remains same, right. So, this connection is a shunt, and I want to subtract or add, we should be the connection, voltage connection should be in series. So, this is a series shunt feedback. In some old book, the terminology they use the output side first and the input side later. So, we will follow as the Sedran-Smith and we will follow this series shunt feedback amplifier. So, if I ask you draw a series shunt block diagram of a series shunt amplifier, so you will be understanding, okay, which kind of amplifier it is? Voltage amplifier. Clear? Because output side is shunt, if it is shunt you are taking voltage, same voltage. Input side is in series, series means only voltage, if you connect them in series they will be added or subtracted depending on the connection configuration. So, this is okay, I hope, right. This is another example. The way we use R2 and R1, the same in circuit level it is drawn. So, this is one amplifier, this is another amplifier. From this output we are taking back to the input. So, output it is voltage, we are subtracting also voltage. So, this is a voltage amplifier, example of a voltage amplifier. You see this is which kind of amplifier? Common source, source is common. What is the gain of a common source amplifier? Minus GM RD. So, this output, this node is what? Voltage. You are taking a portion of that voltage and subtracting from the input side. So, this is a voltage sampling, voltage mixing. Okay. Now, one interesting thing is there. See, my input voltage was Vs, clear, and what I am doing, this is a negative feedback, I am adding or subtracting in the input side, negative feedback, subtracting Vs minus Vf. So, total voltage is getting increased or decreased? Decreased, right. So, you see this Vs is, Vf is subtracted from Vs and this lowers the Vi. Okay. So, this is causing the input current to be smaller, clear. So, the effective voltage is now less. So, because of this my effective input current will be also less. So, from the source, what is my source? This is my source, Vs is my source, original source, this is in between, this is happening, right. Okay. So, because of this Vs minus Vf, my II is getting reduced and my Vs by II, if II is reduced, this term will be increased, clear. My source voltage remain unchanged Vs, but internally what I am doing? Vs minus Vf. because of that my current is, input current is reduced, but my overall resistance that the source is looking, that is Vs by Ri, Vs remain unchanged, but Ii remain reduced. So, my Ri is increased. So, negative feedback helps in increasing the input impedance. Okay. Similarly, see the output resistance will also decrease. Okay. See this feedback, what it is trying to do, it is trying to, let us see this. I have an amplifier, right. So, this is my say differential voltage and its gain. So, its V0 is equal to A into Vd, clear. I have a op amp, its differential input plus and minus differential input is Vd and gain is A. So, what is V0? V0 is equal to A into Vd. Now, what is Vd? V0 by A. If A is infinite, what is Vd? 0. What is the meaning? That the error, the feedback amplifier is trying to reduce the error to 0, because its gain is so large. So, in other way what we can tell, that this feedback is trying to keep this V0 as constant, clear. If the error is 0, my V0 will not fluctuate. So, you see this feedback works to keep the V0 as constant, because Vd is V0 by A, that is close to 0, it is unchanged, means you think that Vd is unchanged. If Vd is unchanged, V0 is forced to constant, right. So, V0 is forced to constant. Thus, if current drawn from the amplifier output change by delta I, the change in del V in V0 will be lower than it would happen if feedback were not present. Thus, the output resistance del V0 by del I0 will be lower than that of the open loop amplifier. Okay. So, what is our output impedance? Del V0 by del I0. See this open loop amplifier and this closed loop amplifier, what is happening, you see this current drawn from the amplifier output changes by del I. Suppose I am drawing some current, okay, and because of that V0 is changing by delta V. Okay. Now, what they are saying, this delta Vi in closed loop is less than the delta Vi in open loop. In open loop, this is forcing us to keep it as constant as possible. Okay. So, this delta V0 by delta I0 will be lower in case of open loop amplifier, and so it will be, my R0 will be lower in case of negative feedback. We will see this example in the next problem also. See, this is our circuit. Whatever A and beta that we are drawing, same thing is drawn. Okay. This A is replaced by a 2-port network. This beta is also replaced by a 2-port network. Okay. So, what we know? Say this is its input side, this is its output side, and for the amplifier this is its input side and this is its output side. So, this beta is just flipped, because this is its input, this is its output. So, it is just flipped, otherwise it is same thing. input to output one Ri is there. Here we are considering that Ri is infinite, okay, and one dependent voltage source is there and a output resistance is there. Ideally R0 is 0 and Ri is infinite. Now we will have to calculate this Ri and Ro. Okay. So, as we discussed here that because of this negative feedback this difference voltage is reducing, right, Vs minus Vf. So, this effect we can consider as open loop our voltage source was Vs. Because of this negative feedback we can consider that Vi is reduced by 1 plus A beta. Okay. The way we explained here that because this negative feedback delta V is I is reduced and so our Ri is getting increased. So, that same is modified here that our Vi is equal to Vs by 1 plus A beta. So, from this we will calculate the I input current. What is input current? Vi by Ri. Okay. So, what is Vi? Vi is this, we will put this Vs by Ri into 1 plus A beta. Okay. So, our modified input impedance is, you see Ri is increased by 1 plus A beta times. Okay. So, what we said that by the same times the gain is reduced, by the same times the input impedance will be increased. Okay. So, using negative feedback my input impedance is increased, and is it helping or is it wanted? What is wanted, right? In voltage amplifier input impedance should be as high as possible. So, negative feedback is helping in increasing the input impedance. Okay. Similarly, to derive the output impedance, what is the procedure for deriving the output impedance? We will add a voltage source. All the input source we will sort it to 0 and we will add a voltage source and we will check the current and we will check Vx by Ix to get the output resistance. Okay. So, you see input is sorted, the Vs is sorted to by S and S dash they are sorted. Okay. So, what we are doing? We have added a voltage source Vx and we are trying to find out the current Ix. So, Vx by Ix we will try to find out. So, what is Ix? Vx minus, there is a voltage source dependent source. So, Vx minus AVI by R0. Okay. And this Vi, now there is no Vs, previously what was our Vi? Vs minus Vf, now Vs is 0, so it becomes minus Vf. So, we will put that in this equation, we will put that, and what is Vf? Beta times V0. So, we will put all of these and we will get closed loop output impedance is equal to Ro by 1 plus A beta. So, input impedance was increased, but output impedance is decreased. So, again negative feedback is helping in reducing the output impedance. So, what are the takeaway? The effect of negative feedback on voltage amplifier. 1, gain is reduced by 1 plus A beta times input impedance increased by same times output impedance reduced by same factor. 3 important points, right? Okay. So, what we can conclude, that I had an open loop amplifier with an input impedance, a gain block, a output impedance, right. I had a Ri, I had a Ro. The same thing I used in a feedback, and I see the closed loop RIF is much increased, ROF is much decreased, gain is decreased. Clear? So, this is the basic concept, and same concept you will be reading in control system. Okay. Same feedback you will be reading. So, from a circuit knowledge point of view, we are having this concept, and same can be utilized in control theory also, and you will be finding it easier to understand there. So, this is one example of another amplifier. This is what kind of amplifier? Current amplifier. So, in current amplifier, the terminology will be current mixing, current sampling, and previously it was series shunt. It will be just opposite. So, it is shunt series. Okay. Voltage and current is just easy, means you will just have to exchange. So, now can you tell me what is your requirement? The negative feedback will, input impedance will be decreased, output impedance will be increased, just opposite to the voltage amplifier. Next is transconductance amplifier. Okay. So, output side is I. If you want to take a portion of the current, you have to make it in series, so that same current flows, right. Unless it is in series, same current will not flow. The moment you will be making a parallel circuit, a portion will flow there, a portion will flow there, it will be divided. But if you want that same current should flow, it has to be in series. So, that is you see it is in series, the amount is coming here, the amount should go back. Clear? And input side is voltage. What is it? Transconductance, I by V. Output side is I, input side is V. So, output side is what? Connection is series. Input side voltage, if you want to add or subtract, it should be in series. So, it is series. Transconductance is series. So, you just think little bit, then you do not need to remember. You think logically, you will be understanding, and your confidence will also go up. Now, you can tell me what is trans resistance? Resistance, what is resistance? V by I. So, output side is V, input side is I. If I want to take a portion of the output voltage without disturbing the output, same voltage, it should be in parallel, shunt. So, this is shunt. Input side I want to give back current, subtract. So, that should be shunt, because series means same current flows. I want to subtract, add or subtract. So, this is also shunt. So, trans resistance is shunt. So, terminology you understand? Now, we will be reading this voltage amplifier in little bit details. We already have certain knowledge that this is a voltage amplifier. Another topology, another naming is voltage mixing, voltage sampling, another is series shunt negative feedback amplifier. Okay. So, how so? So, always remember the basic block diagram A beta. Okay. So, there is a one summer, this is summer, this is plus, this is minus, this is our Vs, this is going to the Vi is going to the main amplifier A, this is my output V0, a portion of that is coming through the feedback and feedback is getting subtracted in the summer, this is my Vf. Same thing I am drawing in a bigger way. So, do not get confused, clear? How we are doing the A? I have a input portal, input resistance, I have an dependent voltage source, I have an output resistance, that is it. So, do not get confused by this big circuit, this is as simple as that. What is my beta? Input impedance I am considering infinite, making it simple. I am having a beta into say Vi and that is it. That I will flip and put it there. Okay. Rest of the connection, if it is series, you do it in series, if it is parallel, you do it in parallel. Okay. So, always try to think from the easiest circuit point of view and then go on building up the bigger circuit, complex circuit. But if you try to look at this problem by this way, you will find it simple. This is a single ended, this is a double ended, that is it. I am taking a one line, there I will take a two line, that is it. Okay. Previously it was a single line, now I am a double line and that is going to the input, that is going to the that input. Next, this output I have to subtract that summer, you see this symbol summer. In physically, if you want to subtract two voltage V1 and V2, what you will do? You will just change it, right, flip it and then connect, then it will become V1 minus Vf, same thing. Okay. So, you see minus sign is going to the here and plus sign is going to the here. Okay. So, again we will do the same calculation and we will be finding out that our input impedance is increased by 1 plus A beta times. Same circuit and this complete circuit is modeled by this complete circuit, closed loop circuit. My input impedance is now RIF, my previously it was open loop was A, now it is AF. So, closed loop gain is AF, previously my output impedance was RO, now it is ROF, F stands for feedback. And we know RIF will be increased and ROF will be decreased. We just did this calculation, so we won't repeat that. And how to do that? Output, we will add a source, we will sort this input and we will try to find out the current and Vx by Ix. And what we figured out? that output impedance is reduced, input impedance is increased. Gain is already decreased, we already know, we have already calculated. Clear? Now, H parameter. H parameter we already did in class, BJT class. So, same thing. So, there are some meaning. Okay. Suppose input voltage we are defining by V1, input current we are defining by I1, output voltage we are defining by V2 and output current we are defining by I2. So, these parameters are related like this way, V1 is equal to H11 I1 plus H12 V2. So, you see this is voltage and H11 into I1, it should be also unit should be come in voltage. Clear? Left side is voltage. So, H11 its unit, it should cancel the unit of current and convert it to voltage. So, what it could be? Impedance V by I, right. H12 it is multiplied with V. So, it will be does it have any unit? It will be unitless. Clear? Left side is voltage, I am multiplying H11 with current. So, H11 should be an impedance. H12 I am multiplying with already voltage. So, it should be unitless. So, what it could be? Some gain or some ratio. Okay. So, you see H11 definition is V1 by I1 when V2 is 0. V2 is 0 means I am sorting it, output is I am sorting. H21 is current ratio I2 by I1. For BJT, what is your current ratio? IC by IB, beta. Can you correlate now? Okay. H11, input voltage VB by IB, what is that? VB by IB R pi. Can you correlate? So, you see same thing, different terminologies. If we draw the small signal model, this is R pi, this is this can be many things, right, GM into VI or beta into IB, so many things, and I can have a output resistance and so on. So, this same thing are defined by this way, and if you satisfy the equation you will get the unit. Similarly, H21 is equal to V1 by V2 when I1 is equal to 0, I1 0 means open circuit, input open. H22 is I2 by V2, that is transconductance, GM. Okay. So, terminologies are like H1 is input impedance at port 1 when port 2 is shorted, H12 is feedback voltage ratio when input port is open, H21 is short circuit current gain when output port is shorted, and H22 is output admittance when input port is open. Okay. So, just from these two equation you will get all of this, and we already did that, just so that you get familiar or you do not get confused, I just repeated it here, but we already did that, do not get worried that what is this. This already we have solved in BJT and MOSFET classes. We may not have used the H terms, but we have used the hybrid pi network. Okay. So, now previously what we did, we neglected this input impedance and source impedance, those we have not put. Now, slowly you see what we are doing, we are making a single block, then we are coming to a bigger, the blocks were replaced by its model, and now we are slowly putting the, here only Vs was there, no Rs was there, we will put Rs. Here no RL was there, we will put RL. Okay, here we have considered infinite input impedance, we will put impedance there. So, putting all the non-idealities, we will try to consider that okay, now the basic thing will remain unchanged, but maybe the figure will little bit modified. We all know the basic things. What are the basic things? Gain will be reduced, input impedance will increase, output impedance will decrease. Now, because of these added parameters, what are the added parameters? One resistance I have added here, another resistance I have added here, another resistance I have added here, another resistance I have added here. Okay. But step by step if we solve, we can get the output. Clear? The way we did previously, step by step, Vi is equal to Vs minus Vf, Vf is equal to what? Vf is equal to beta into V0, V0 is equal to A into Vi. These steps will remain unchanged, right? So, if we solve step by step, we can do all the calculation. So, do not get confused or get carried away by this all this. Slowly one by one single component is getting added. Okay. If we initially started with this big circuit, you will get afraid, right. So, we started with a simpler circuit and we are showing that okay, these are step by step, it is easy, right. So, you just try to understand the concept and what is the meaning. What we are trying to do? We are trying to see the effect of feedback. Okay. What is the effect of feedback? That we will take a portion of the output and we will subtract it in the input side. So, what is the meaning? We are taking a portion of the output and subtracting it from the input side and then multiplying with a very high gain. So, what it is trying to do? It is trying to stabilizing the output. So, same way, same thing, and we will get this input impedance is increased and output impedance is reduced. And there is one problem that we will do in the tutorial class. Okay. So, I would like to stop here and we will continue this problem. I will little bit explain in the class and details will be solved in the tutorial class. Okay. So, we will be studying this in details of voltage amplifier, rest of the amplifier we will be seeing only the simpler version. So, all this complex RS, RL we will consider only for the voltage amplifier. For others amplifier we will only consider the simpler versions. Okay. So, we will conclude here and we will start in next class. Thank you.